Okay, so hello future engineers. This discussion video, we have to discuss about analog to digital conversion and about analog to digital converter, or what we have as an acronym is ADC. So let's start by defining what is an analog to digital converter. ADC stands for analog to digital converter. It is an electronic device used for converting an analog signal into a digital signal. So the analog input signal of ADC is a continuous time and continuous amplitude signal. And the output of ADC is a discrete time, discrete amplitude digital signal. If you could look at this representation here, we could see nga sa aton nga input, syempre analog ang aton nga signal. And as it passes through your ADC, there are certain processes or steps happening in there para ang aton mga output will be a digital form na. So why do we need to perform analog to digital conversion gamit ang ating ADC? We know, based on mga previous discussions, that in real world, every real quantity, such as, for example, your voice, certain temperature, weight, even mga level of fluids or liquids na kinahanglan nato ni measure, they exist in analog state, and it cannot be processed by any digital device. Pareho sa mga ginagamit natin na computers or cell phones. Ang ini nga mga analog quantities are converted into digital form so that ang ato nga digital device can process it. This conversion is done using analog to digital converter. So, ano ang ara sa sulod sa aton nga analog to digital converter? So, amo ni ang aton nga block diagram kung ano ang ara sa sulod sa aton nga ADC. So, the analog signal is first applied to the sample block. Kung nakita ito ni. So, ang ato halin sa aton analog signal or ang signal nga halin sa aton nga raw or mga real-time mga parameters, real-world parameters. So, syempre, kung mabalaan natin or manotice na natin, they are represented by a sine wave, for example. So, continuous time and continuous in amplitude or completely are changing representation. So, diri siya ginakuha siya naton sample sa sample nga block. And then, so dapat may ara kita the sample amplitude value is maintained and held in the hold nga block. So, there is a hold block. So, next, there is an analog value. The whole sample is quantized into the discrete value by the quantized block. So, later on, matamato ni natin discuss na ganyan nga mga blocks. So, i-plus star ni siya natin. At last, the encoder converts the discrete amplitude into binary number. So, kung value kita, in order for us to represent it into its digital form, dapat ang ating output should be in a binary number. So, analog to digital conversion steps. So, sa atong previous na slides, nakita dito natin kung ano ang itsura sa ating analog to digital converter. And kung ano ang mga specific na blocks na kinanglan agyan para ma-perform natin ang analog to digital conversion. So, first dito, ang sample block. So, anong function ini? Ginagamit siya para i-sample natin syempre. Makuha kita sample sa ating input ng analog signal at a specific time interval. Ano ang silingon? So, this means nga hindi naman pwede kuhaon ng kabilugan ng analog signal. So, makuha ito the specific na portion, makuha ito the sample. And then, amo na nga ito nga i-studyhan. The samples are taken in continuous amplitude and possess real value, but they are discrete with respect to time. So, naka-mention man dali nga may ara kita dapat specific time interval. For example, may ara ka signal representation. So, both silingon makuha ka, for example, every 5 seconds makuha ka sample. So, that is a representation na dahil sa ato nga signal. Every 5 seconds makuha ka sample. So, the sampling frequency plays important role in a conversion. That is maintained at a specific rate. The sampling rate is set according to the requirement of the system. Next, we have analog to digital conversion. nga step. So hold nga black. Ano ginahimo sa hold nga black? So basically wala siya amo gina ka significant ka function. Nga ang ginahimo sa hold nga black is just i-hold niya na ang specific nga sample nga amplitude nga nakuha naton kagina sa sampling. Hasta nga makakuha kita sa bago na mga value. So, the whole value remains unchanged till the next sample. So, for example, at the first second, example, kita for example, ari siya, 1 second. So, next, i-hold nyo nga value hasta makakuha ta another value for another nga second. For example, nakakuha ta another value. So, may increase naman siya. I-hold nyo naman ang liwat hasta makalambot ta sa isa naman ka another nga sampling interval. Next, we have the quantize or diri katabo ang ginatawag nato yung quantization. So it converts the analog or continuous amplitude into discrete amplitude. The on-hold continuous amplitude value, hold black goes through quantized black and becomes discrete in amplitude. The signal is now in digital form as it has discrete time and discrete amplitude. So this means, so the conversion natin into its digital pero discrete na values. So we will have a specific na video nga kinahanglan i-discuss natin ang quantization and sampling. So let's leave it na lang sa sila nga video danay. Pero for this one, i-consider ka na lang ang ginahimo natin for quantization is that we are rounding off a specific value into its digital na value. So gina-convert na siya and then gina-round off. Next, we have an encoder in stage. The encoder black converts the digital signal into binary form or into bits. So as we know, the digital devices operates on binary signals, so it is necessary to convert the digital signal into a binary form using the encoder. So kabalo kita nga ang readable format is in binary form. In order for us to use it para sa aton nga application or digital na mga applications, dapat aton nga signal should be expressed or should be converted into its binary na equivalent. So this is the whole process of converting of an analog signal into its digital form using sa aton nga ADC. So take note na tanan-tanan nga process na gin-mention naton happens in just a microsecond. Okay, I have here some of the factors na kinahanglan natin maintindihan when we talk about ADC. So resolution of an ADC is the number of bits that represents the digital signal's amplitude. So, ano ang resolution? Nakabatian siya natin kada permi for the video, for a picture resolution, for a TV ng mga shows. The analog signal has continuous amplitude. It can have infinite values. So sa dali, gina-describe lang nato anong analog signal and ano man ang kinalain niya with your digital signal. So digital signal naman niya, may discrete siya kag finite number of values. So medyo naintindihan tayo na niya. So to better understand the idea of resolution of ADC, I have here. So for the first stage, we have 1-bit resolution. The figure above shows an analog signal represented in a digital form, which is either 0 or 1. So this is a 1-bit resolution. So the resolution sa aton ADC defines its number of steps. Kung makita ninyo, dali sa aton signal, ang blue line is the aton representation. So maghampal ta steps, ang aton nga daw steps sa hagdanan. So we have 1 ari sa dalom and then we have 2 dali sa babaw sa mingalang ng digital. So that means may duwa kita ka step. So paano determine ang number of steps? Paggamit naton sa formula nga 2 raised to the power of n, where n is the number of bits. Therefore, there are 2 steps in 1-bit na resolution. Hindi man na ang nagkakatabo with your 2-bit resolution. For 2-bit resolution, multiply ito lang siya by, or substitute ito lang ato ni n by 2. So that means 2 squared is equal to 4. That means, na may ara kita apat ka step, we have 1, 2, 3, 4. So we have 2-bit resolution. Same is true with your 4-bit resolution. So 2 raised to the power of 4 is 16. Thus, we have a 16 step that is ato nga representation. So the number of steps increases exponentially with increase in the bit resolution. It also implies by increasing the bits of resolution, the converted digital signal becomes more likely the original analog signal. Okay, so take note na samtang ginapagamay natin ang value. So, maano siya, makuha niya gid ang naka-original gid na signal, especially for example if curve niya ang signal. So, kinahanglan natin damuon ang aton nga number of bits kay para makuha natin ang specific original signal. So, next, so ideally we can say nga kung ang aton nga digital signal infinite ang iyang resolution or damo-damo o gagmay-gagmay na lang ang aton nga spacing, pwede kita makuha ang given naton nga analog signal. Another parameter na kinahanglan naton maintindihan is the width of the step. Ano yung width of the step? The voltage difference between two adjacent steps is known as width of the steps. So kung nakita natin kanina, so ang difference between sigma. Since it is represented by delta V, that means we have delta, so we will have a difference. So a single step represents a fixed voltage, that is your delta V, represented by your reference voltage divided by 2 raised to the power of n. So take note of the formula. Ang mangyayang formula for the width of the step. So where Vref is the maximum voltage being converted, and n represents the number of bits of resolution. So, ang walang mani, for example, we are given 10.24 volts reference voltage, and then we have your N. So, diretso ito naman siya, butang dire para makuha natin ang value natin, which is 0.01 volt para sa ating step size or width sa ating step. Okay, so in this, a single bit increase represents a 0.01 volt of increase in analog input. If the analog input is increased by 0.01 volt, then the output is increased by 1 bit. So, kung remove ka by 0.01 volt sa imong input, amo na yung change ato niya output to 1 bit. Next one, quantization error. Ang bago kagina in the process of quantization, ginahimo naton is the conversion into its digital format. So the ADC updates its value if the increase or decrease in its input voltage is greater than the delta V over 2. So in other words, the difference between the input and digital round-off figure of the output is known as the quantization error. So because of the possible na change or the possible na round-off na matabo naton sa ating signal, there will be possibly a discrepancy or may ara da nga laing nga values i-round off to siya. That means ang ina nga natabo ang ina nga process ang ginahimo naton will create an error. So ang ina nga error ginahitawag siya naton as quantization error. So paano naton i-avoid ang quantization error? Dapat i-increase naton ang resolution sa aton nga ADC. Okay? So para mag-decrease man ang step size sa aton nga representation or graph. Next one, we have your sampling rate na parameter. The number of samples taken during a single second is known as sampling rate or sampling frequency. So, take note, kapila ka mag-sample in 1 second. That is your sampling rate. So, the sampling rate should be set according to the input signal. It should not be very low or very high. So, for example, the result na representation. So, kung tanawin natin sa graph, kadua kita ng example. Una, adding a first ni vertical. Next nga kadua nga vertical, which is 2.1. So, this example shows that the sampling rate is 0.5. Kaya may ara kita 1 divided by 2 ka sample. Next, we have the term nga aliasing or aliasing. If the sampling rate is very low, kung gamay-gamay o nubo-nubo ato nga sampling rate, so amo ni siyang matabo. Ang ginatawag natin nga aliasing. So, it will become a different signal after reconstruction because ang aton goal is to reconstruct the signal. So, because of the representation naton, there is a tendency if gamay-gamay ang aton nga sampling rate, nubo-nubo at nga sampling rate. So, ang tendency hindi na naton reconstruct ang original signal. So para ma-avoid natin ang aliasing, so we have to kept higher sa aton nga sampling rate, higher than twice sa aton nga frequency sa input signal. Take note, para ma-avoid ang aliasing, imo dapat sampling rate or fs should be twice or be higher than twice ang imo nga original nga input frequency. Okay, but in the modern mga devices ginagamit naton, we have already anti-aliasing filters or may mga filter na nga ginagamit in order to avoid sa aliasing sa aton nga or aliasing sa aton nga mga gina-perform ng mga operations. Next, another term diri is Nyquist criteria. Ano po siling sini? Ang Nyquist criteria, this one gasuggest lang na siya nga dapat ang aton nga minimum possible sampling rate for an analog signal which can be reconstructed successfully. So, dapat undergo sini or dapat sundon ni. If the highest frequency of the analog signal is f, the signal can be reconstructed successfully from its samples kung ang aton nga sample are taken at a sampling frequency greater than 2f. So, para ma-avoid natin or dapat para ma-reconstruct siya nga successful gid, dapat ang nga sampling frequency dapat greater sa twice sa aton nga analog frequency. So, take note of Nyquist criteria. Next, we have offset. So, the offset, so maghambal ka offset a difference between the voltages ginagamit natin kung mag-shift kita sa aton nga digital output. So that is your offset. So sa diin, ang nakakinanglan natin sa dihan ang ADC. So because kabalo kita, we are in the advancement of technology, especially sa courses natin na ginatake subong. So dapat natin insindihon kung ano ang ADC. In the modern world of growing technology, we are dependent on digital devices. These digital devices operates on digital signal, but not every quantity is in digital form. So kabalo kita, aton mga ginapang measure are or raw mga parameters na ginagamit natin is measured in analog form. They are in analog. So an ADC is used para i-convert ang aton yung analog signals into digital signals. So ari ang sum of but not limited to sa mga applications. Number one, very common din butang kontra is cell phones. It operates in digital voice signal. Originally, ang aton nga voice is in analog form, which is converted through ADC before siya i-feed sa aton nga cellphone transmitter. Next, we have images and videos, mga selfies ninyo nga gina-capture gamit ang camera. Para ma-store mo siya sa imo digital device, dapat i-convert siya dana into its digital form using ADC. Next, medical imaging. Para sa X-ray kag MRI, kagamit mo siya sa ADC para i-convert ang image into digital form before modification. Next, syempre mga music. So para ma-store ta sila into CDs, so kinahanglan na mag-agi sila sa aton nga ADC converters. Next, oscilloscope. So may ara na siya sa isa daw component which is ADC. So, ang ginagamit na for delay purposes and different other features. So, ang mga ginagamit ng mga equipments, so may ara siya ADC. Next, air conditioners contains temperature sensors for maintaining the room temperature. This temperature is converted into digital form using ADC so that onboard controller can read and adjust the cooling effect. So, ang gina-measure natin nga analog nga value sa temperature, ang man siya gina-convert into its digital value para makontrol ta siya. So, that is for the some mga applications of ADC. Take note that in today's modern world, halos tanan ng mga devices na ginagamit natin is using digital signals. So, ara nakita si digital version of communication. They need to have ADC in it. because it has to operate in digital domain which can be only acquired using ADC or analog to digital converter. So, ang muna siya ka-importante ang ADC. So, para sa modern communication. So, and also para mapuslan naton ang ginapang measure naton yung mga sensors nga or ang mga ginapang measure sa aton mga sensors ng mga raw ng mga parameters. So, the counterpart of this nga is the digital to analog converter or suli naman sini will be discussed in another video. And we will have another video for the quantization and sampling. So para sa next na discussion video. So this is it for now. Thank you. Stay safe.